This video is on isotopes. We're going to take it old school and I'm just going to work through some problems with you. So we've looked at the definition of isotopes. An isotope is when you have, if it's an atom, the same number of protons, but it's going to have a different number of neutrons. The symbol means neutrons, this one means protons. Protons are positive, neutrons are neutral. So we can have the same atom but have different isotopes, meaning they have different number of neutrons but the same number of protons. So we kind of have some review vocab over here. Here is an example of two isotopes of strontium. Strontium-90 has 38 protons, 38 electrons, and 52 neutrons. We'll go over and review how to find these again, but just for now, let's use the numbers that are given. We have 59 neutrons. We notice that strontium-86 has 38 protons, 38 electrons, and 48 neutrons. There is a 4-number difference between these two. This is going to be your mass number, and we'll look at what this is in a second. This is your hyphen notation. And these are also off by 4 too. So you have strontium-90. The main difference is the number of neutrons. So isotopes is all about the neutrons. What is atomic mass? Atomic mass is going to be, for example, here is hydrogen. You would come over here to the periodic table and you could find hydrogen on it. That average atomic mass is going to be the weighted average. It's also known as the decimal, or the one that has a couple numbers. It's always going to be the larger number on the periodic table, your average atomic mass. If you round the average atomic mass, that gives you your mass number. So for example, if this was our average atomic mass, 87.62 AMU, that's the unit, atomic mass unit, then we could take this number and we could round to 88, because that 6 tells us to round up, so I rounded up to 88. We have to have a whole number because you can't have half of a proton, half of an electron, or half of a neutron. This number is my mass number. The mass number is not on the periodic table over here. You're always going to take that big number at the bottom and you're going to have to round it to a whole number to get the mass number. So, the mass number is going to be your protons plus your neutrons. So this mass number here is going to be protons plus your neutrons. And again, we got this number from the average atomic mass from the periodic table. I'm going to write PT for periodic table. So, from the periodic table. So all of that was review information. Be sure to come in and ask help if you have any questions on these. Let's look at some new information. Symbol notation. It's just a simple way to write all of this information so we have it in one place. It's always going to be written the same way. You're always going to have an element symbol in the middle, and then you're going to have your mass number at the top. A lot of times it'll be represented by an A, and then you're going to have your, pick a different color, your atomic number on the bottom, which is usually represented by Z. So this is my atomic number. Remember, that's going to tell me the number of protons for an atom. That means that also my protons will be equal to my number of electrons. This number is going to be your mass number. This number is what you're going to round the number on the periodic table to get a whole number. So this one is not found on the periodic table. You have to round it to a whole number. That mass number is going to be your protons plus your neutrons. So in order to find the number of neutrons, we're going to do our mass number. Sorry, I'll write it up here. Our mass number minus our atomic number, and that will give us our neutrons. Because atomic number is your protons, your mass number is your protons plus your neutrons. So if we subtract out the protons, we will get our neutrons. So here we have an example again with strontium. Strontium's symbol is Sr. So the element symbol is Sr. Notice that the first letter was capitalized and the second letter is lowercase. Next, we can add our atomic number. Now, here we're given the atomic number of 38, but if we didn't know that, we could come over to the periodic table, so right over here, and see that it is 38. That's the identity. It's the ID. If it has the same number of protons, it's the same atom. The mass number. The mass number is going to be found by going to the periodic table, and you're going to round that number to a whole number. Notice that this one is telling us that it's 90, but on the periodic table it says 87.62. So the average atomic mass equals, on the periodic table, I'm going to write on PT, 87.62 AMU. So typically we would round that and we'd get 88. But remember, there's isotopes, and we'll learn more about how this number is found tomorrow, but sometimes this number changes, and if you're given the information, then that's how we know that we have a different mass number. So in this case, we were just told it was strontium 90. See how it's also written here with the element and then the mass number, or the symbol and the mass number. So we're going to put a 90 as our mass number. So sometimes this number is not what's on the periodic table. If you're given information, go with the information you're given. If you're not given any information, then you fall back to the periodic table. So again, this is our symbol notation. The symbol goes in the center. At the top, you will have your mass number, and the bottom, your atomic number. And then for your hyphen notation, you're going to either write the element name out, hyphen, and then you put the the mass number. Or you can write the symbol. So this is called your symbol notation. These are your hyphen notation. So let's take a look at some atoms and see if we can fill in the chart. So taking a look at this chart here, we see that it's giving us the hyphen notation, and then it's also writing the one with the symbol hyphen notation there. So we're going to fill all these items in. So we're going to find the hyphen notation, the atomic number. How do we find the atomic number? That's going to be from the periodic table. Our mass number. There's two ways to find this now. If you're given info, and that's what all of this is saying up here. If you are not given the number of protons and neutrons, then you use the periodic table. But if you are given them, then we do not use the periodic table. We use what is given. So if you're not given, we'll say info on neutrons and protons, then you use the periodic table. Okay, then we're going to find our number of protons, and we'll find our number of electrons, and our number of neutrons. I'm going to switch this because on your paper it's in this order, and I want to make sure we're on the same page. So protons are positive, neutrons are neutral, electrons are negative. All right, so we are given that we have chromium, (53). The hyphen notation using the symbol is just going to be the symbol. So if you don't know the symbol, you would go to your periodic table and you would look for chromium. Now, we know the mass number is 53, so that's helpful. So when we're looking, we can get close to 53-ish. Oh, look, this is around 51. Chromium, because that's an isotope, that's why the mass number is different. So chromium is going to be Cr, capital C, lowercase r. So sometimes you're just going to have to search on your periodic table, and the more that you use this, the faster it'll go for you. And then we'll write hyphen 53. Again, that 53 is our mass number. So I'm going to come down here and write 53. Our atomic number is from the periodic table, so we go back to the periodic table, and we see that it is 24 for the atomic number. Great. Now we have all the information we need to find the number of protons, neutrons, and electrons. So to find our number of protons, our protons and our electrons are going to be equal to the atomic number. So 24 protons and 24 electrons. To find the number of neutrons, it's a little bit different. We're going to have to take our mass number, 53, minus our atomic number, 24, and then we can do some math, or you can pull out your handy-dandy calculator. 53 minus 24 gives you 29. So we have 29 neutrons, 24 protons, and 24 electrons. That's because this is an atom, so our protons and our electrons were the same. Let's try the next one. I'm going to reuse what I have up here and just put a piece of paper over it. Put a little thicker piece of paper over it. Okay. So, we don't know what our hyphen notation is with the element, but it does give us C-14. So we go to our periodic table, so we come over here and we look for C. Oh, here it is, carbon. So the hyphen notation with the element name would be carbon-14. Again, this number is your mass number. So I can go ahead and come down here and write 14. To find our atomic number, we can simply just look on the periodic table. So we look at carbon. The small whole number is your atomic number, so it's going to be 6. So remember, your atomic number for an atom is going to be the number of protons, and it will also tell you the number of electrons here. So the number of protons that we have is going to be 6, because our atomic number is 6. Our number of electrons is also going to be 6, because it's an atom, so they need to be equal to each other. Make it easier. For our neutrons, we have to do a little bit of math. So 14 minus 6, you can put it in your calculator, do it in your head, but 14 minus 6 gives us 8. So we have 6 protons, 8 neutrons, and 6 electrons. If we had used the number on the periodic table, so I'm just going to give a different example that's not on the paper just to compare. So this is carbon-14. Carbon-12, if I had used the number on the periodic table, 12.011 would have rounded to 12. So that would mean that my mass number was 12. I would still have 6 protons and 6 electrons. The protons and the electrons would not change. What would change would be that mass number. So 12 minus 6 gives me 6. We have 2 less neutrons in carbon 12 as compared to carbon 14. All right, so we forgot to do some things on these. We forgot to add the symbol notation. So to do the symbol notation, we're going to write down here our symbol notation. You're always going to put the symbol in the center. On the bottom is your atomic number. So in this case it was 6. And then our mass number goes on top. So that would be the symbol notation for carbon 14. So the 6 is on the bottom, 14 on the top, my mass number over my atomic number. It's always going to be big over small. And also, for chromium 53, we could just write the symbol as Cr, that's the symbol. Our mass number goes on top, so 53, atomic number on bottom. So this would be our symbol notation. All right, let's try that other example there. So we were given I'm going to write it over here so you can see it, but we were given that it was magnesium. Mg is magnesium. I know that that is magnesium because I can come to the periodic table and find Mg and it has the name of it. Now this only has the mass number, but we can simply find the atomic number by locating on the periodic table. And we see that the small whole number is 12. So that means the atomic number is 12. That 12 also means I have 12 protons and 12 electrons. So our atomic number, just to review, is 12. Our mass number is 26 because that was given to us. We have 12 protons, 12 electrons. To find our neutrons, we're going to take the top number minus the bottom number. So you could kind of think of it like this if you have the symbol notation. So that 26 minus 12 gives me 1, so 14. So 14 neutrons. All right, so we have everything written except for our hyphen notation. So we just have to write out magnesium. You can capitalize or you can lowercase the first letter in the element. Both are correct. Magnesium dash 26. Then we can use the symbol M, capital M, lowercase g, that does matter, dash 26. All right, let's look at one more example here. This time we're given the number of protons, neutrons, and electrons, so we got to figure out what element we have here. So we are told that we have 16 protons, 16 neutrons, and it says 34 electrons, which is a mistake. So that should be electrons. The first thing we want to do is identify what element this is. So which one of these gives us the identity? Protons. Protons are going to tell us the identity of the element. Identity. All right, and since it's an atom, these two are going to be the same, and we see that, so that means that this is an atom. So we're going to use the 16, and we're going to come to our periodic table, and we're going to look at the atomic numbers. Notice that the atomic numbers go 1, 2, 3, 4, 5, 6, all the way across to 10. We need to get to 16, so we keep going. 16. Sulfur. So sulfur is going to be our element. I can write sulfur hyphen. And how can we find our mass number? In this case, we can solve for it. So we're going to add our protons plus our neutrons. So 16 protons plus 18 neutrons. That was the information given to us. Equals 16 plus 18, 34. See your mass number that was there earlier. All right, so there's our mass number is 34. Our atomic number is 16. So we're going to come here, and we have all the information we need, so we can put the 34 up here, sulfur -34, or use the symbol -34. And the last thing we need to do is the symbol notation. So the big S goes in the center, capitalized. On the bottom, you're going to have your atomic number, and on the top will be your mass number. So that would be your symbol notation. Go ahead and let's go to the next page. This one tells you what the difference is with ions. So ions are basically the same thing, but now we have a charge, meaning that our electrons are not going to be the same. So it gives you some information, just kind of reminding you of that. So let's give these examples a try. So again, we are going to find our hyphen notations. Mass number, atomic number, protons, neutrons, electrons. Okay, and our symbol notation. Okay, so first, the only information we're given is 37 chlorine with a -1. So the first thing we want to do is find that atomic number by going to the periodic table and finding chlorine. It's number 17 on the periodic table, and so the atomic number is going to be 17. So I can write that up here. Our mass number is coming from the symbol notation, so our mass number is 37. The number of protons is equal to the atomic number, so 17. The electrons is different because we have a charge, so we're going to take our protons minus our charge. So our number of protons is 17 minus a -1 charge. When you subtract two negatives, it's like you're adding them together. So we actually get 18 electrons. And finally, our neutrons are going to be 37, our mass number, minus 17, that's your atomic number. So we have the protons plus the neutrons in that mass number, minus the number of protons, is going to be equal to 20 neutrons. So we have our protons, our neutrons, and our electrons. So we're just going to write chlorine -37, or capital C, lowercase l, 37. All right, let's do another one. Just two more to go. So we have down here again 26 magnesium and a 2+. We can find the atomic number for magnesium over here, which is 12 on the periodic table. And our protons is 12. Electrons, well, we have a 2+ charge, so we're going to say 12 minus a +2. So we have 10 electrons. Our neutrons is going to be our mass number minus our atomic number. So we are going to get, you can put in your calculator, but you have 14 neutrons, protons. So we can go up and fill our mass number is 26, atomic number is 12, and we can write out our symbol and hyphen notations. Capital M, lowercase g, 26. All right, pause the video and try the last one on your own. All right, here we go, last one. This time, again, we're only given protons, neutrons, and those electrons. We don't have a symbol notation. We know this 19 tells us the identity, so the number of protons is going to be 19. So we come over here and we see that that is potassium. So I can go ahead and write that symbol in and write the name in, potassium. We know that the atomic number is 19. I can fill that in. Our mass number is going to be our protons, that's 19, plus our neutrons, 18. Add those together, and we get 37. 37. Good, time to use a calculator. So, potassium 37, potassium 37. And then we put 37 here, but we got to figure out what the charge is. So we're going to add, to figure out that charge here, our protons plus our electrons. So we have 19 protons, which are positive, plus a negative 17, so we get a positive 2. So this is a 2 plus. Let's double check everything. We have 19, 18, 17. Yeah. This tends to have a +1 charge, but I guess I was just switching it up in there. All right. If you have any questions, please come to my help session. Tuesdays and Thursdays from 1:30 to 2:30. I can do small group help on Wednesdays, and I'm always available via Remind. Have a great day.